Hi all, I'm Salil, an NVIDIA AI practitioner and your guide for this course on Microsoft Azure AI Fundamentals. This is the path that you would take if you are trying to get the certification, which is AI-900, and there are multiple units in this course. So Microsoft AI Azure Fundamentals, or rather Microsoft Azure AI Fundamentals, has multiple modules, and the first module that we'll start with today is the Azure AI Fundamentals overview module. And once we go through that, we will pick it up and go through a knowledge check at the end of the module and take it from there. Hope that you are excited for what is coming, and feel free to check through the entire playlist. We have done these sessions in live before, but this is a more condensed and shorter version of the same. Hope you love it. If you do, feel free to show the love. Thanks for your time. You have a wonderful day. Bye.
Introductions. AI enables us to build amazing software that can improve healthcare, enable people to overcome physical disadvantages, empower smart infrastructure, create incredible entertainment experiences, and even save the planet. Watch the following video to see some ways that AI can be used.
Artificial intelligence isn't coming. It's here. It's the defining technology of our time. But it's human ingenuity that makes it so powerful. Jane started losing her vision when she was 12.
California Street.
She uses seeing so powerful. Jane started losing her vision when she was 12.
California Street.
She uses seeing AI,
I
crept down the stairs and out the door,
which enables her to read and navigate her world. Microsoft AI is helping farmers adapt to climate change,
We can use technology to help feed the world without wrecking the planet.
enabling wildlife conservation,
The ability to use AI really democratizes science. WildMe uses images from any source to help study endangered species.
and creating new ways for people with hearing loss to communicate.
I want the exact same information that my hearing friends have.
It's more than just imitating intelligence or sounding like a human. Microsoft AI is changing every industry, from healthcare
And now you can see these finite details, the relationship with many structures.
to engineering and telecommunications.
We are using artificial intelligence to change the way we are relating to customers.
AI lets us put people first.
The Microsoft tools really enabled us to breathe digital life into an iconic brand persona.
The product that we make is not a thing in a box. Microsoft AI empowers others to create experiences and potential. This is just the beginning.
artificial intelligence, it's just opened up this whole world.
The future we invent is a choice we make.
What is AI? Simply put, AI is software that imitates human behaviors and capabilities. Key workloads include machine learning. This is often the foundation for an AI system and is the way we teach a computer model to make predictions and draw conclusions from data. Computer vision, capabilities within AI to interpret the world visually through cameras, video, and images. Natural language processing, capabilities within AI for a computer to interpret written or spoken language and respond in kind. Document intelligence, capabilities within AI that deal with managing, processing, and using high volumes of data found in forms and documents. Knowledge mining, capabilities within AI to extract information from large volumes of often unstructured data to create a searchable knowledge store. Generative AI, capabilities within AI that create original content in a variety of formats including natural language, image, code, and more. Next unit, understand machine learning. Continue. Having an understand machine learning. For minute. Machine learning is the foundation for most AI solutions. Since the 1950s, researchers, often known as data scientists, have worked on different approaches to AI. Most modern applications of AI have their origins in machine learning, a branch of AI that combines computer science and mathematics. Let's start by looking at a real-world example of how machine learning can be used to solve a difficult problem. Sustainable farming techniques are essential to maximize food production while protecting a fragile environment. The Yield, an agricultural technology company based in Australia, uses sensors, data, and machine learning to help farmers make informed decisions related to weather, soil, and plant conditions.
Right now, artificial intelligence helps us meet the needs of today so we're prepared for tomorrow.
By 2050, we need to produce 60% more food. So how are we going to feed the world without wrecking the planet? Using Microsoft artificial intelligence, we can reduce waste and produce more food. Any grower will tell you every row, every crop is different. We can use Microsoft AI to make local predictions about light, wind, rain. This helps farmers know when to plant, irrigate, and harvest. It's making a difference.
Artificial intelligence helps farmers grow more while wasting less.
How machine learning works. So how do machines learn? The answer is, from data. In today's world, we create huge volumes of data as we go about our everyday lives. From the text messages, emails, and social media posts we send to the photographs and videos we take on our phones, we generate massive amounts of information. More data still is created by millions of sensors in our homes, cars, cities, public transport infrastructure, and factories. Data scientists can use all of that data to train machine learning models that can make predictions and inferences based on the relationships they find in the data. Machine learning models try to capture the relationship between data. For example, suppose an environmental conservation organization wants volunteers to identify and catalog different species of wildflower using a phone app. The following animation shows how machine learning can be used to enable this scenario. A team of botanists and scientists collect data on wildflower samples. The team labels the samples with the correct species. The labeled data is processed using an algorithm that finds relationships between the features of the samples and the labeled species. The results of the algorithm are encapsulated in a model. When new samples are found by volunteers, the model can identify the correct species label. Approaches to AI have advanced to complete tasks of much greater complexity. These complex models form the basis of AI capabilities. Machine learning in Microsoft Azure. Microsoft Azure provides the Azure Machine Learning Service, a cloud-based platform for creating, managing, and publishing machine learning models. Azure Machine Learning Studio offers multiple authoring experiences such as automated machine learning. This feature enables non-experts to quickly create an effective machine learning model from data. Azure Machine Learning Designer, a graphical interface enabling no-code development of machine learning solutions. Data metric visualization, analyze and optimize your experiments with visualization. Notebooks, write and run your own code in managed Jupyter Notebook servers that are directly integrated in the studio. Next unit, understand computer vision. Understand computer vision. 5 minutes. Computer vision is an area of AI that deals with visual processing. Let's explore some of the possibilities that computer vision brings. The Seeing AI app is a great example of the power of computer vision. Designed for the blind and low vision community, the Seeing AI app harnesses the power of AI to open up the visual world and describe nearby people, text, and objects.
Seeing AI is a Microsoft research project for people with visual impairments. The app narrates the world around you by turning the visual world into an audible experience. Point your phone's camera, select a channel, and hear a description. The app recognizes saved friends.
Jenny near top right, 3 feet away.
Describes the people around you, including saved friends.
Jenny near top right, 3
channel, and hear a description. The app recognizes saved friends.
Jenny near top right, 3 feet away.
Describes the people around you, including their emotions.
28-year-old female wearing glasses looking happy.
It reads text out loud as it comes into view, like on an envelope.
Ken Lawrence, P.O. Box,
or a room entrance.
Conference 2005.
Or scan and read documents like books and letters. The app will guide you and recognize the text with its formatting.
Top and left edges not visible. Hold steady. Lease agreement. This agreement.
When paying with cash, the app identifies currency bills.
$20 US.
When looking for something in your pantry or at the store, use the barcode scanner with audio cues to help you find what you want.
Campbell's tomato soup.
When available, hear additional product details.
Heat and microwave bowl on height.
And even hear descriptions of images in other apps like Twitter by importing them into Seeing AI.
A close-up of Bill Gates.
Finally, explore our experimental features like scene descriptions to get a glimpse of the future.
I think it's a young girl throwing a frisbee in the park.
Experience the world around you with the Seeing AI app from Microsoft.
Computer vision models and capabilities. Most computer vision solutions are based on machine learning models that can be applied to visual input from cameras, videos, or images. The following table describes common computer vision tasks. Expand table. Task.
Description.
Image classification. Image classification involves training a machine learning model to classify images based on their contents. For example, in a traffic monitoring solution, you might use an image classification model to classify images based on the type of vehicle they contain, such as taxis, buses, cyclists, and so on. Object detection. Object detection machine learning models are trained to classify individual objects within an image and identify their location with a bounding box. For example, a traffic monitoring solution might use object detection to identify the location of different classes of vehicle. Semantic segmentation. Semantic segmentation is an advanced machine learning technique in which individual pixels in the image are classified according to the object to which they belong. For example, a traffic monitoring solution might overlay traffic images with mask layers to highlight different vehicles using specific colors. Image analysis. You can create solutions that combine machine learning models with advanced image analysis techniques to extract information from images, including tags that could help catalog the image or even descriptive captions that summarize the scene shown in the image. Face detection, analysis, and recognition. Face detection is a specialized form of object detection that locates human faces in an image. This can be combined with classification and facial geometry analysis techniques to recognize individuals based on their facial features. Optical character recognition, OCR. Optical character recognition is a technique used to detect and read text in images. You can use OCR to read text in photographs, for example, road signs or storefronts, or to extract information from scanned documents such as letters, invoices, or forms. Computer vision services in Microsoft Azure. You can use Microsoft's Azure AI Vision to develop computer vision solutions. The service features are available for use and testing in the Azure Vision Studio and other programming languages. Some features of Azure AI Vision include image analysis, capabilities for analyzing images and video and extracting descriptions, tags, objects, and text. Face, capabilities that enable you to build face detection and facial recognition solutions. Optical character recognition, OCR capabilities for extracting printed or handwritten text from images, enabling access to a digital version of the scanned text. Next unit, understand natural language processing. Continue. Understand natural language processing. For me, natural language processing, NLP, is the area of AI that deals with creating software that understands written and spoken language. NLP enables you to create software that can analyze and interpret text in documents, email messages, and other sources, interpret spoken language, and synthesize speech responses, automatically translate spoken or written phrases between languages, interpret commands, and determine appropriate actions. For example, Starship Commander is a virtual reality (VR) game from Human Interact that takes place in a science fiction world. The game uses natural language processing to enable players to control the narrative and interact with in-game characters and Starship systems.
So think about this. How often are you alive when the dawn of a new medium comes out? I knew that I had to be a part of VR because there are no rules for what VR should be. Starship Commander is a choose-your-own-adventure VR narrative that uses natural language processing, so you can actually have a real conversation with the characters.
I'm Sergeant Sarah Pearson. I've been assigned to your wing today.
When we started making Starship Commander, we had to figure out, how do we get technology that can understand what a person's saying so that we can have these new narrative experiences? We're a science fiction game. We come up with new words. No off-the-shelf software could let us put in custom words.
Who are the Echnians?
In our story, the bad guys are called the Echnians. And every time we said Echnian, it would come up with really weird words that were similar to other things that you would say. And so it would get confused all the time. So we needed to make sure that we could supply our own script. We started using Microsoft Cognitive Services to power the backend of Starship Commander.
Looks cool.
Once we plugged custom speech service into Starship Commander, I had tears in my eyes when I was playing it because it's like, oh my God, this is it. This is the experience we want.
Open the hatch.
Voice print accepted. Welcome, Commander.
You can essentially put your script in there and it knows, oh, these are the ways that people are going to talk. And these are the phrases that they're going to say.
Cool. What's my mission?
It must be something pretty important.
And then the second thing too was the intent detection. With Lewis, you basically give it a couple statements. After you've given it a couple statements, you crunch it and you start typing in your own statements. And it's shockingly scary how good it picks up even stuff that you didn't put in there.
Computer, use autopilot and let's be on our way.
Autopilot engaging.
I have never seen an opportunity like this where there's a wide open playing field. No one's written the rules yet. There's going to be tons of amazing software out there, and I just can't wait to see what other people write.
Natural language processing in Microsoft Azure. You can use Microsoft's Azure AI Language to build natural language processing solutions. Some features of Azure AI Language include understanding and analyzing text, training conversational language models that can understand spoken or text-based commands, and building intelligent applications. Microsoft's Azure AI Speech is another service that can be used to build natural language processing solutions. Azure AI Speech features include speech recognition and synthesis, real-time translations, conversation transcriptions, and more. You can explore Azure AI Language features in the Azure Language Studio and Azure AI Speech features in the Azure Speech Studio. The service features are available for use and testing in the studios and other programming languages.
Understand document intelligence and knowledge mining. 100 XP.
3 minutes. Document intelligence is the area of AI that deals with managing, processing, and using high volumes of a variety of data found in forms and documents. Document intelligence enables you to create software that can automate processing for contracts, health documents, financial forms, and more.
Document intelligence in Microsoft Azure.
You can use Microsoft's Azure AI Document Intelligence to build solutions that manage and accelerate data collection from scanned documents. Features of Azure AI Document Intelligence help automate document processing in applications and workflows, enhance data-driven strategies, and enrich document search capabilities. You can use pre-built models to add intelligent document processing for invoices, receipts, health insurance cards, tax forms, and more. You can also use Azure AI Document Intelligence to create custom models with your own labeled datasets. The service features are available for use and testing in the Document Intelligence Studio and other programming languages. Knowledge mining. Knowledge mining is the term used to describe solutions that involve extracting information from large volumes of often unstructured data to create a searchable knowledge store. Knowledge mining in Microsoft Azure. One Microsoft knowledge mining solution is Azure AI Search, a private, enterprise search solution that has tools for building indexes. The indexes can then be used for internal-only use, or to enable searchable content on public-facing internet assets. Azure AI Search can utilize the built-in AI capabilities of Azure AI services, such as image processing, document intelligence, and natural language processing to extract data. The product's AI capabilities makes it possible to index previously unsearchable documents and to extract and surface insights from large amounts of data quickly. Next unit. Understand generative AI. Understand generative AI. 100 XP. 2 minutes. Generative AI describes a category of capabilities within AI that create original content. People typically interact with generative AI that has been built into chat applications. Generative AI applications take in natural language input and return appropriate responses in a variety of formats, including natural language, image, code, and audio.
Generative AI in Microsoft Azure.
In Microsoft Azure, you can use the Azure OpenAI service to build generative AI solutions. Azure OpenAI service is Microsoft's cloud solution for deploying, customizing, and hosting generative AI models. It brings together the best of OpenAI's cutting-edge models and APIs with the security and scalability of the Azure Cloud Platform. Azure OpenAI supports many foundation model choices that can serve different needs. The service features are available for use and testing in the Azure OpenAI Studio and other programming languages. You can use the Azure OpenAI Studio user interface to manage, develop, and customize generative AI models. Next unit, challenges and risks with AI. Challenges and risks with AI. Artificial intelligence is a powerful tool that can be used to greatly benefit the world. However, like any tool, it must be used responsibly. The following table shows some of the potential challenges and risks facing an AI application developer. Expand table. Challenge or risk. Example. Bias can affect results. A loan approval model discriminates by gender due to bias in the data with which it was trained. Errors may cause harm. An autonomous vehicle experiences a system failure and causes a collision. Data could be exposed. A medical diagnostic bot is trained using sensitive patient data, which is stored insecurely. Solutions may not work for everyone. A home automation assistant provides no audio output for visually impaired users. Users must trust a complex system. An AI-based financial tool makes investment recommendations. What are they based on? Who's liable for AI-driven decisions? An innocent person is convicted of a crime based on evidence from facial recognition. Who's responsible? Next unit, understand responsible AI. Understand responsible AI. 100. At Microsoft, AI software development is guided by a set of 6 principles designed to ensure that AI applications provide amazing solutions to difficult problems without any unintended negative consequences. Fairness. AI systems should treat all people fairly. For example, suppose you create a machine learning model to support a loan approval application for a bank. The model should predict whether the loan should be approved or denied without bias. This bias could be based on gender, ethnicity, or other factors that result in an unfair advantage or disadvantage to specific groups of applicants. Azure Machine Learning includes the capability to interpret models and quantify the extent to which each feature of the data influences the model's prediction. This capability helps data scientists and developers identify and mitigate bias in the model. Another example is Microsoft's implementation of responsible AI with the Face service, which retires facial recognition capabilities that can be used to try to infer emotional states and identity attributes. These capabilities, if misused, can subject people to stereotyping, discrimination, or unfair denial of services. For more details about considerations for fairness, watch the following video. Reliability and safety. AI systems should perform reliably and safely. For example, consider an AI-based software system for an autonomous vehicle or a machine learning model that diagnoses patient symptoms and recommends prescriptions. Unreliability in these kinds of systems can result in substantial risk to human life. AI-based software application development must be subjected to rigorous testing and deployment management processes to ensure that they work as expected before release. For more information about fairness, AI systems should treat all people fairly. Fairness. AI systems should treat all people fairly. For example, suppose you create a machine learning model to support a loan approval application for a bank. The model should predict whether the loan should be approved or denied without bias. This bias could be based on gender, ethnicity, or other factors that result in an unfair advantage or disadvantage to specific groups of applicants. Azure Machine Learning includes the capability to interpret models and quantify the extent to which each feature of the data influences the model's prediction. This capability helps data scientists and developers identify and mitigate bias in the model. Another example is Microsoft's implementation of responsible AI with the Face service, which retires facial recognition capabilities that can be used to try to infer emotional states and identity attributes. These capabilities, if misused, can subject people to stereotyping, discrimination, or unfair denial of services. For more details about considerations for fairness, watch the following video.
So right now, we do live in a society that is unfair and biased in many different ways. And I think the whole point of focusing on fairness in AI systems is to make sure that the systems that we develop and we deploy reduce unfairness in our society rather than keep things at the same level or even make it worse. And for me, that's really the goal. We've seen a lot of news stories over the past couple of years about AI systems that are used to allocate or withhold opportunities, resources, or information in domains like criminal justice, employment and hiring, finance, credit. AI systems can reinforce existing societal stereotypes. Another example would be cultural denigration. We also have over and under representation. There isn't a single definition that we can easily quantify and just integrate into our systems. Fairness relates to not just the system, the technical component, but it relates to the societal context in which the system is deployed. And that means that fairness, in the context of AI systems, is a fundamentally socio-technical challenge. This means that we've got to have a greater diversity of people developing and deploying AI systems. And what we see is that the assumptions and decisions made by teams at every stage of the AI development and deployment lifecycle can introduce biases. And that's why this is such an important topic. This isn't something that we can just sort of delegate to one or two people and call it quits and move on. No, this is something that everybody has to be thinking about really actively.
Reliability and safety. AI systems should perform reliably and safely. For example, consider an AI-based software system for an autonomous vehicle, or a machine learning model that diagnoses patient symptoms and recommends prescriptions. Unreliability in these kinds of systems can result in substantial risk to human life. AI-based software application development must be subjected to rigorous testing and deployment management processes to ensure that they work as expected before release. For more information about considerations for reliability and safety, watch the following video.
Reliability and safety is a concern for every AI system we develop. We need to make sure that the systems we are developing are consistent with the design ideas we have and working in a way that it is consistent with our values and principles. And this requires that our systems, our models, are not creating harm in the world. And if there are situations where they may be making mistakes, we actually push products out there with quantified and well understood risks and harms in a way that we actually share that with our users. This is kind of the guiding principle we have with respect to reliability and safety. And it is really a concept that applies to every AI product we have in the company. When we think about safety, the first examples that come to mind are self-driving cars. But it's not even limited to those physical systems, physical agents. We actually worry about harm to human lives when a machine learning model is making predictions about people's health in hospitals, when they are making predictions about diagnosis. Wrong systems can lead to harms for people. So those are the cases that we really worry about because the threat is to human lives. But this doesn't mean that this issue is only for those physical systems. Reliability is a big concern, and small mistakes may pile up when a system gets used many times across a large group of people. And that's why it is a concern for everything that we build.
Privacy and security. AI systems should be secure and respect privacy. The machine learning models on which AI systems are based rely on large volumes of data, which may contain personal details that must be kept private. Even after the models are trained and the system is in production, privacy and security need to be considered. As the system uses new data to make predictions or take action, both the data and decisions made from the data may be subject to privacy or security concerns. For more details about considerations for privacy and security, watch the following video.
Privacy is a fundamental right, and Microsoft has a long-standing commitment to privacy and security in the systems and products that we build. With AI and machine learning, we add new complexity to those systems and an increased reliance on using data to develop those systems, to train the systems. That increasing reliability on data adds new requirements for keeping the system secure. For example, we're using more data. We need to ensure the protection of that data, that it's not leaked or disclosed. One of the ways we approach that is to not remove the data from a customer's device, to run the models locally on the device, eliminating that potential vulnerability. When we consider the security aspects of these AI systems, you have to think through where and how the data is coming from. If it's user-submitted data or a public data source that's being used in the prediction, how do you prevent that from being corrupted? Having things like anomaly detection or other systems for detecting changes in the data that might indicate that there's an adversary trying to influence the results of the system.
Inclusiveness. AI systems should empower everyone and engage people. AI should bring benefits to all parts of society, regardless of physical ability, gender, sexual orientation, ethnicity, or other factors.
If we think about what we're really trying to achieve, we want to make sure that we as Microsoft empower and engage the communities around the world, making sure that no one is left out, making sure that we are intentionally inclusive and intentionally diverse with the approaches that we take towards AI. We want to make sure that that full spectrum of communities are covered. And if we truly think about how we can design for the 3%, we can then solve for the 97% at the same time. We want to make sure that experiences like seeing AI, speech-to-text translation out of PowerPoint, and other technological examples that we have that we're building upon, including the Microsoft accessibility standards, represent just an example of the extensive toolkits that we have here to ensure everyone truly designs for an inclusive AI future. As a woman of trans and non-binary experience, and also being Latinx as part of the underrepresented minority community, ensuring that these future experiences are truly representative of the underserved minority communities, we need to make sure that they're involved both in the earliest concepts and feature design and planning, but making sure that they're part of our testing, that we are also building with side by side individuals to make sure that we are not taking an ableist perspective for the population we intend to serve.
Transparency. AI systems should be understandable. Users should be made fully aware of the purpose of the system, how it works, and what limitations may be expected. For more
Transparency and intelligibility can help us achieve a really diverse range of goals. So things from mitigating unfairness in machine learning systems, to helping developers debug their AI systems, to gaining more trust from our users. There are two sides to transparency. In part, transparency means that the people who create AI systems should be open about how and why they're using AI, and also open about the limitations of their systems. Transparency also means that people should be able to understand the behavior of AI systems. This is what you often hear referred to as interpretability or intelligibility.
Accountability. People should be accountable for AI systems. Designers and developers of AI-based solutions should work within a framework of governance and organizational principles that ensure the solution meets ethical and legal standards that are clearly defined. For more detail,
despite all the complexity with these new models and with new technology that can be somewhat unpredictable and somewhat hard to interpret, we are still accountable for how our technology impacts the world. Second, I think about accountability as the structure that we put in place so that we make sure that we consistently are enacting our principles and that we're taking them into account in everything that we do. Also, part of our accountability is to help our customers and partners be accountable. We have a set of principles that guide how we develop and how we sell and how we advocate for regulation on facial recognition, because we feel like all three of those pieces are really critical to be accountable. We think it has a lot of great uses, and we also think there are a lot of uses that could interfere with people's civil liberties or push society in a direction that we're really not interested in supporting.
So in moving from our facial recognition principles to practices and processes that we can follow across the company, what we've had to do is to take a high-level principle, such as our commitment to fairness, and think about how do we have our development teams view every stage of the development lifecycle with those principles. So today we have a set of guidelines that they can follow and think about these sorts of considerations at every step of the life cycle. And that's really a first in this company, and I think in many other places outside this company as well.
the principles of responsible AI can help you understand some of the challenges facing developers as they try to create ethical AI solutions. Summary 1. Artificial intelligence enables the creation of powerful solutions to many kinds of problems. AI systems can exhibit human characteristics to analyze the world around them, make predictions or inferences, and act on them in ways that we could only imagine a short time ago. With this power comes responsibility. As developers of AI solutions, we must apply principles that ensure that everyone benefits from AI without disadvantaging any individual or section of society. All units complete. Complete module.
So with this, we've completed the AI Fundamentals Overview module, and the next module is Fundamentals of Machine Learning, which we'll take up next, and I will see you in that lesson with Fundamentals of Machine Learning. Hope you have a wonderful day, morning, evening, or night, whatever time it is at your location. See you soon.